Hello YouTube fam. Welcome back to our channel. In this channel, we will be discussing various topics in the exciting world of AI, machine learning, and computer vision. Our content is crafted by our awesome human team, but here's the magic. It's finely tuned and optimized by our AI wizards, bringing you top-notch information. And guess what? The presentation is delivered to you by our AI hosts and voiced by our incredible AI avatars. Let's get started. In today's video, we will look at automatic speech recognition and transcribing and translating spoken language from audio files. We will use OpenAI Whisper model as base model. We will fine-tune the model to recognize Punjabi language speech. We will use an open-source common voice dataset consisting of an MP3 and corresponding text file. Once we've fine-tuned the model, we will create a Gradio interface to transcribe speech in Punjabi. In today's video, we will look at how to fine-tune a Whisper audio transcribe model. This work incorporates insights and code snippets courtesy of Hugging Face, published on Hugging Face's blog. We extend our gratitude to the original authors and Hugging Face for sharing their valuable resources with the community. Let us look at basic concepts. First, what is Whisper? Whisper is an audio processing model developed by OpenAI, designed for robust speech recognition and capable of transcribing and translating spoken language from audio files. It leverages deep learning techniques to understand and process audio inputs with high accuracy, even in challenging environments with background noise or different accents. Whisper aims to bridge communication gaps by providing accessible and efficient audio-to-text conversion. Next, we will understand what is PEFT, Parameter Efficient Fine-Tuning. Parameter Efficient Fine-Tuning, PEFT, refers to a set of techniques in machine learning aimed at updating large pre-trained models in a way that requires altering only a small fraction of the model's parameters. This approach is particularly useful when working with very large models, where full model retraining can be prohibitively expensive in terms of computational resources and time. In the context of parameter-efficient fine-tuning for machine learning models, LORA and QLORA refer to specific techniques designed to update large pre-trained models more efficiently. LORA, or low-rank adaptation, is a technique used to fine-tune large pre-trained models in a parameter-efficient manner. Instead of updating all the parameters of a model, LORA focuses on adapting only a small set of parameters, typically by introducing and training low-rank matrices that modify the weights of specific layers, like the attention or feed-forward layers in a transformer model. This approach allows for significant customization of the model to new tasks with minimal changes to the overall parameter set, preserving the original strengths of the pre-trained model while adapting it to specific needs. Imagine you have a huge, complex book representing a large pre-trained model that you want to customize slightly without rewriting the whole thing. LORA allows you to do just that by adding a few notes or annotations, small changes to some pages, making the book more relevant to your specific needs without altering its original content significantly. In technical terms, LORA introduces small, trainable adjustments to certain parts of the model while keeping the vast majority of the original parameters fixed. This makes the fine-tuning process much more efficient, as you're only tweaking a tiny fraction of the model. Let us see what is QLORA, or quantized low-rank adaptation. Quantization, in the context of machine learning, involves reducing the precision of the numerical representations used in a model. For example, reducing floating point numbers from 32-bit to 8-bit integers. This process helps decrease the model's memory footprint and can speed up inference, making the model more efficient, especially on hardware with limited computational resources or specific accelerators designed to work with lower precision arithmetic. Building on the previous analogy, if LORA is like adding handwritten notes to the book, QLORA is akin to using a shorthand or a more condensed notation for those notes. QLORA further compresses the changes you make, the annotations or notes, by quantizing them, which means representing these adjustments with fewer bits. This not only makes the fine-tuning process more efficient, but also reduces the memory and computational resources needed to apply these customizations. In very simple terms, Both LoRa and QLoRa are about making smart, minimal updates to a large pre-existing knowledge base, the pre-trained model, to adapt it for specific tasks. LoRa does this by adding small modifications, and QLoRa goes a step further by compressing these modifications to be even more resource efficient. We will run this code on Google Colab with T4A4 GPU. First up, install the required libraries. Transformers. Transformers provides APIs and tools to easily download and train state-of-the-art pre-trained models. Accelerate. Accelerate enables the same code to be run across different distributed configurations. PEFT, parameter efficient fine-tuning. Datasets for accessing and sharing data. Bits and bytes for quantization. All right, let us decide the base model to fine-tune. We will use the OpenAI Whisper Small as base model. We will fine-tune on the Punjabi language data. We will use Common Voice 30 dataset from Mozilla Foundation. Accept the terms of use on the Hugging Face Hub. We will only consider the input audio and transcribe text for fine-tuning. Now let us do data prep. The automatic speech recognition pipeline can be decomposed into 3 stages. A feature extractor, which pre-processes the raw audio inputs. The model, which performs the sequence-to-sequence mapping. A tokenizer, which post-processes the model outputs to text format. In Transformers, the Whisper model has an associated feature extractor and tokenizer called Whisper Feature Extractor and Whisper Tokenizer, respectively. Now that we've prepared our data, we're ready to dive into the training pipeline. The Hugging Face trainer will do much of the heavy lifting for us. All we have to do is define a data collator. The data collator takes our pre-processed data and prepares PyTorch tensors ready for the model. Evaluation metrics. During evaluation, we want to evaluate the model using the word error rate, our metric. Load a pre-trained checkpoint. We need to load a pre-trained checkpoint and configure it correctly for training. Define the training configuration. This will be used by the trainer to define the training schedule. Once we've fine-tuned the model, we will create a Gradio interface to transcribe speech in Punjabi. Now let's load the pre-trained Whisper checkpoint. Again, this is trivial through use of transformers. To reduce our model's memory footprint, we load the model in 8-bit. This means we quantize the model to use Porth precision when comma-paired to float32 with minimal loss to performance. Finally, we need to apply some post-processing steps on the 8-bit model to enable training. We do so by first freezing all the model layers and then cast the layer norm and the output layer in float32 for training and model stability. Let's load a PEFT model and specify that we are going to use low-rank adapters, LORA, using getPEFTModelUtility function from PEFT. In the final step, we define all the parameters related to training. We will then run trainer.train. We can see the training loss going down after few steps. Now that our model is fine-tuned, we can push the model onto Hugging Face Hub. This will later help us directly infer the model from the model repo. We've successfully fine-tuned our model. Now let's run inference on it. We will use Gradio's GR interface. We will use GR audio for microphone input. We can see some sample screenshots of the fine-tuned Whisper transcribe model output. The model does transcribe data, but it might need more finituning to put the letters in Punjabi language. Thanks for watching. Stay tuned for more exciting adventures in the world of AI and machine learning and algorithms. If you found this video helpful, don't forget to hit that like button. Subscribe for more tech talks and ring that notification bell to stay updated on our future explorations. Until next time, happy coding and keep the curiosity alive. Thanks for watching.